oxygenator. The oxygenator is designed to add oxygen and remove carbon dioxide from the venous blood during cardiopulmonary bypass. It used in two principal modes in cardiopulmonary bypass and in extracorporeal membrane oxygenation to oxygenate blood in longer term life support. Cardiopulmonary bypass used during cardiac surgery. Oxygenation of venous blood and carbon dioxide elimination. Oxygenation of venous blood and carbon dioxide elimination. Excellent gas exchange. Minimum blood trauma. Soft wall biocompatibility. Minimize inflammatory reaction. Small priming volume. Minimize hemodilution. Easily assembled and safety, minimal failure incidents and easy to replace during cardiopulmonary bypass in the event of oxygen failure. Parts of membrane oxygenator: blood inlet, recirculation, blood outlet, blood sample, arterial, gas outlet, water inlet and water outlet, gas inlet, vent port, venous, temperature port, remover port from the remaining blood. Main functions of oxygenator: reservoir functions, deforming, filtration and contain the blood. Membrane oxygenator functions, gas exchange and heat exchange. Type of oxygenators: bubble oxygenator, membrane oxygenator. Bubble oxygenator. The typical bubble oxygenator is divided into two sections. The first section is mixing chamber, where fresh gas flows into blood through a screen, which causes small bubbles to form. The oxygen is transferred from the bubbles into blood, and carbon dioxide transferred from the blood into bubbles. The second section is reservoir, where blood is deformed and contained in it. Hot cell venous reservoir. Parts of hot cell venous reservoir contain venous blood outlet, water out, water inlet, and heat exchanger, arterial blood outlet. Venous reservoir as shown in this video. Heat exchanger parts are shown in this figure. Heat corner inlet port, heat corner outlet port, and heat exchanger, packed coupler, membrane gas exchangers, and blood reservoir, blood outlet port as shown in this figure.
The main advantage of bubble oximeter is the low resistance to flow and low pressure drop across the oximeter compared with membrane oximeters. The disadvantage of bubble oximeter is the direct contact between the blood and air that permit to formation of gas emboli.
Membrane oxygenator that aim to utilization of the material as a gas exchange membrane to make physical separation between the blood and gas O2 and CO2. This makes an artificial oxygenation more similar to oxygen in the lung. This material must be very thin with minimal resistance to blood and compactable. Membrane oxygenator. Membrane oxygenator. The membrane is consisted of plastic housing made of polycarbonate which contains the gas exchange membranes and water circuit. It is designed to be used to gas exchange and heat exchange. The venous blood enters from the membrane inlet port and leaving from the membrane outlet after provided with oxygen and get rid of carbon dioxide. Membrane oxygenator as is shown in this figure. The main advantages of membrane oxygen over bubble oxygenators is the avoid of direct contact between the blood and air in the membrane oxygen, which prevents the formation of bubbles. Some natural or synthetic materials are permeable to gases. These materials are used by some researchers to make gas permeable membranes. Cardiatomy reservoir. There are two types of reservoirs: flexible venous reservoir, soft cell reservoir, hard cell venous reservoir. Cardiatomy reservoir, blood reservoir, is a device used in cardiopulmonary bypass or contain the volume of blood that displacement out of human circulation during the operation. Soft cell reservoir. The soft cell reservoirs have the advantage of increase and reduce its size according to the amount of blood that they contain, and they are not have airspace that prevent the accidental delivery of air to patient. The venous blood enter in the reservoir through the inlet port and passes through the microscreen and aspirate from the outlet port by the head pump to the oxygenator inlet. The inlet port portion is above the outlet port, which puts a larger volume above the outlet port, which promotes mixing, prevent vortex, optimize air removal, and promotes low venous resistance. Soft shell reservoir, as is shown in this figure, there is an inlet and outlet port. Hard shell venous reservoir. Hard shell venous reservoir is a hard plastic container made up of polycarbonate. Contains an integral filter mechanism. The venous blood enters from the venous inlet port and passes through a deformer, polyurethane foam, and depth filters and screen filters, which results in the two filtration the blood from particulate materials before leaving the venous outlet of cardiotomy. Hard shell venous reservoir. Hard shell venous reservoir consists of a venous inlet and venous outlet, deformer, depth filter, and screen filter. The advantage of rigid reservoir: easy volume measurement and management of venous air, larger capacity, easier to prime, and permit suction from vacuum, assist venous drainage. Disadvantages include micro air bubble due to possibility to form the vortex and increase activation of blood elements. The blood temperature is controlled through a water circulation. The priming volume of the oxygenator can be adjusted by selecting different sizes and lengths of microporous polypropylene or silicon fibers. Low priming volume reduce hemodilution. Microporous polypropylene fibers is highly permeate to oxygen and most other common gases. Microporous polypropylene is hollow fiber structure. The microporous polypropylene hollow fiber is the most membrane oxygenator is actually used. The gas exchange in the membrane occurs by diffusion through the membrane wall and transit via microporous. When microporous membrane oxygenator is used, it is extremely important the pressure in the blood side must always exceed the pressure in the gas side to prevent the possible of entering any gas emboli from gas side to blood side via microchannel. The surface tension of the blood prevents plasma water from entering the gas side of membrane during CPV and prevent gas leak into the blood side. Flat sheet membrane microporous sheets folded envelope design. In flat sheet microporous membrane oxygenators, the membrane is flat sheet which folded to create plates that separate a blood compartment from the gas compartment. The flat, plain microporous membrane oxygenators are more effective in trapping and expelling air bubble. The may actually enter the membrane oxygenator, but they have a larger surface area than the hollow fiber oxygenator and demand larger priming volume. There, the folded membrane type microporous oxygenator has been suspended by hollow fiber oxygenators. Integrated arterial filter oxygenator. Integrated arterial filter oxygenator is a new generation of hollow fiber oxygenator with integrated arterial filter. It has a screen filter surrounded the hollow fiber layer of the oxygenator to trap and or remove particulate and air embolia from the blood before return to arterial line. Integrated arterial filter oxygenator as shown in this figure. The gaseous emboli that may be present in the blood or trapped in the screen filter mesh keep contact with the hollow fiber, driven by the pressure difference blood side 100 m to 300 mHg. Gas side gaseous emboli enter the inner lumen of microporous hollow fiber and are eliminated via the gas outlet. It has better dimensional stability, heat resistant, and chemical resistant. Blade kept on one side of the membrane and gas exchange on the other side. The membrane provides a complete partition between the blade and gas so that the transfer depends totally on diffusion of gas through the membrane material. In general, the blood flow through the oxygenators are passes in the radial or axial path. The path of blood flow is affecting oxygenating efficiency, air emboli, removal pressure drop, and heat exchanger performance. The blood enters the oxygenator from the blood inlet and passes through the heat exchanger first and then through the oxygenator blood before exiting from the blood outlet low point oxygenator to prevent air emboli. In general, blood flow as is shown in this figure. Perfusion talks. Like but don't forget to subscribe Perfusion Talks.